Thank you for doing that. Go ahead and close that for us. All right. So let's say I don't really want to study too much for the quiz, so I just think I'll listen and take a look at the screen here and take a look at it. And is there anything on this page that you said we need to review that?
No.
That's pretty fast. Okay. What do you think? Which page? Okay, let's go to the next page. What about this? What about classifying reactions? Are you pretty solid with that? Okay. Is this your class? Did we do this yesterday? Yeah.
For the complete combustion,
Uh-huh.
is the product always going to be CO2 plus H2O?
If it's complete combustion.
Okay.
We talked about this a little bit in the candle lab. Incomplete, you would have soot, like just plain carbon. You might have carbon monoxide produced, but for complete combustion, you'd have only carbon dioxide and water. Good question. Yes.
On number 7 for the product, maybe it wasn't 9, but you changed to 18. Can you say the reason?
Okay, so on a combustion reactor, there are some combustion reactions that are actually easy to balance, but here's where you fall into a trap. If you ever have a combustion reaction and it looks, see this 18? It looks like I should put a 9 here because 9 times 2 is 18. But if you ever put an odd number in front of the water on a combustion reaction, it will not balance. So what's our trick here? If you're supposed to put a 9 here, you don't put a 9. What are you going to put? 18. What if you're supposed to put a 3 here? 6. Everybody got that? So that's a trick that nobody ever taught me. I remember being frustrated with some of these combustion reactions, and I didn't know there was a trick to it. Good question. Do we, how do you classify this one? Did we do that yesterday?
No.
All right, what do you think it is? Who said that? Very good. That's very good. Isn't that a synthesis? Okay. All right. Now, let's go to this page, and what I'd like you to do is, have any of these we haven't classified yet? Which ones have we not done? Did we not do this one? Okay, what do you think? Look at it right now, and what do you think? And if you remember one of my tricks, I said, whenever you have hydroxide on one side of the arrow and water on the other side of the arrow, if you draw water as HOH, now see if it's easier now. Can you classify it now? What is it? Single? Let's take a look. The reason it's not single is because this is made of 2 parts and this is made of 2 parts. So the Na is going to kick the hydrogen out, but what's the hydrogen going to do? Yeah, so what is it? Double replacement. All right, what about this one? Can you see this as a lead and nitrate? Can you see it as A and B? Can you see it that way?
Yeah.
Okay, so what do you think? All right, double replacement. Okay, and what about number 8? What's number 8?
Single replacement.
Very good. You guys are very good. Okay. Next, how about number 10?
Single replacement.
Excellent. Okay. All right, now what I want you to do is just take a couple minutes and you're supposed to balance these, all right? Did we do any of these yesterday? How many did you do? Most of them? 2? Okay. All right, let's go ahead. Now, remember, I do require you, in this case, if you take a look, there's 1 sodium here and there's 2 here, so what are you going to do here? 2 here, right? Now that gives you how many hydroxides? How many hydroxides is that? 2. But how many hydroxides do you have here?
1.
All right. Okay, now watch now. How many hydrogens does that give you that are not in hydroxide? There they are. Are they balanced?
Yes.
How many sulfates on the left? Don't say 4.
1.
Okay, how many on the right?
1.
Ooh. What do you think?
Yes.
All right, let's go ahead and I want you to practice. I will tell you that number 7, I threw that on there. I like this one. It's hard. There's no trick. I have no tricks for that. So go ahead, I want you to take the next 5 minutes. I want you to balance all these. And if you want to sit with somebody, you said, hey, can we talk about these? And then we'll get into what the harder part of the chapter, okay? So let's take 5 minutes and do the sort of the easy kind. You just balance it. Number 7 is going to be hard. Number 7 will be difficult for you. And as soon as nobody in the other class got number 7. I only gave them 5 minutes, but nobody in the other class did number 7. They couldn't figure it out. And if you want to talk to your neighbor, you can, or you say, no, I think I'll try it by myself. Hopefully, while you're doing these, you're seeing these little tricks. Do you remember the little tricks we had? Like on number 1, did you see the odd, even mismatch? Everybody see that? On number 3, the trick was there was a water on one side and hydroxide on the other, so I wrote water as HOH. That's trick number 2. You have to be honest with me. If there's something like that, we know I'm having a little trouble with number 3 or number 6. You have to be kind of honest about this and say, I'm not sure how to do these. Which one? Unfortunately, I don't have any tricks for number 7. It's just like you have to stay with it, trial and error, trial and error, trial and error. So anyway, we're going to see if anybody in here figures it out. Do you have number 7?
Yes.
Wow. Wow. All right, I'll call on you when everybody's done.
Yeah.
Like I said, I only gave them 5 minutes, but nobody in the other class could get it. And so far, nobody in this class except you has got it. So keep trying to get number 7.
I think so.
Just double check it. There's a lot of things to check. Now, do you notice that nitrate did not stay as nitrate?
Yes.
So now you have to do nitrogen atoms. Not okay. Well, good. All right. Well, hang on. Just do the rest of them then. If you go ahead and finish it,
Yeah.
I'll call on you for number 7. Did you get number 7, Sally? You got it? All right. Can you go back there and see if your numbers match hers? Now, if they don't match, then just see what happened. Maybe you left one out, but don't tell anybody. Just you guys are the only 2 that got it right. Maybe. Now you can skip number 7, and we'll come back to that, okay? Because that is a little different one. Look at that. That's great teeth. Look at that. That's what I like. Education. Look at that. Right? Everybody's helping each other. That's beautiful. And you guys are talking to each other. I like that. Dave, you have them all done except number 7?
Yep.
Are you still working on 7?
Still thinking of it.
Okay. Riley, what are you doing? How you doing? What number are you on? 10? Oh, good. Good. Libby, you got number 10 done?
I don't know how to do this.
Oh, any of them? Okay, so that's what I need to know, okay? That's what I need to know. All right, one more minute, and then we're going to show everybody how to do all these, and that's, if you don't mind, just pay a lot of attention when we go over them, okay?
Yeah.
And then you'll be all right. You'll be all right. 7's the only one that will be hard for anybody.
Yeah.
But the rest of them, I know you can do them. I know you can do them. All right, one more minute. Did you guys match? Did your numbers match or not match?
They didn't match.
They did?
No, they didn't.
Oh,
They were a little bit,
So, are both wrong? One of you right?
we're both wrong.
Good. Good. So you guys put your heads together. I'll call on you in a minute, and you can do number 7 see if you can try it.
I'm just not sure how you do it when the
Which one?
acid, like 7, like when the atoms like 7.
Okay, so what happened is, the reason that this is probably hard is, see how nitrate did not stay as nitrate? Now you have to balance each atom, like just nitrogen.
So can you put numbers in between them? I don't understand.
Oh, no, huh? Hey, excellent question. Hey, let's everybody come on back to your seats. I'm gonna stop. Everybody stop what you're doing. Come back to your radar seats. Great question. The coefficient will never be in between. The coefficient always is in the front, and it goes for everything after that. Just like in math, that would do the same thing. Now, the coefficient will always be put in front of something or not at all. That's called coefficient. Now, let's take a look at number 1. And when I call on you, I want you to sound something like this. On number 1, when I look through here, I noticed there was an odd even mismatch. O2, O3. I want the number of oxygens on the left to equal oxygens on the right. Well, how can you get an odd and an even number to equal each other? You can't, except what's the smallest number they both go into evenly? 6. What times 2 is 6?
3.
And what times 3 is 6? See, see the coefficient, Libby? Okay, now watch. What's 3 times 2 oxygens? How many is that? 6 oxygens on the left of the arrow. What's 2 times 3? 6 oxygens on the right. That means they're balanced. I counted for every atom. But now, how many aluminum atoms does that give me? 4. See that? 2 times Al2. So I only had 1 here, and I need to balance it like that. Now, you also always check to see if it can be reduced. Can this be reduced? Okay, then we're done. All right, let's call on somebody who volunteered for number 2. I'm listening, all right?
Okay, so on the left we have 1 mercury and 1 oxygen.
Let's do one at a time. Let's do one element at a time.
Well, that we have 1 mercury on the left and 1 mercury on the right.
That's balanced.
And then we have 1 oxygen on the left and 2 oxygens on the right.
Oh, how are you going to do that?
So we just multiply, or we put 2 in front of the H2O.
A coefficient, right?
Yes, and now we balance out the oxygens.
2 times O1 is 2 O's, right?
Yes.
2 O's.
But now we have 2 hydrogen, or 2 not hydrogen, 2 mercuries and 1 mercury, so we need to put a 2 in front of the
All right,
oxygen.
now can you reduce this? Ooh, it looks like you could, but you know what? There's a 1 there. As long as anybody has a 1 coefficient, you can't reduce it, can you? Good job. Volunteer for, how about volunteer for we did number 2, didn't we? We did that in class. Okay, let's do number 3. How about 4? A volunteer for 4, Larissa. Eureka.
So you start off with the oxygen. You see that on the right side you have 3 oxygens.
That's 3.
And then on the other side you have 2.
That's an odd even mismatch.
Right?
That's an odd even mismatch, isn't it?
Yes.
Okay, so what are you gonna do about it?
So for the right side you're gonna put 2.
Oh, in this one, in front of this one?
You're gonna put 2.
Because 2 times 3 is 6 oxygens, and then what?
You're gonna put 3 oxygens on that side. And then on the right side you have 4 ions, so you're gonna put 4 in front of the
All right, can you reduce this?
No.
Okay, then you're done. Good job. All right, who wants to volunteer for number 5? Yes.
So the leads, the PV are the same. We have 1 on the
1 lead.
Yes, and then 1 on the right
Okay.
side. So that's balanced. And then you have the nitrate, and there's 2 of those. So on the right side.
Okay, I'm gonna stop you just for a second. Everybody, did everybody hear what she said? one of the tricks is if the polyatomic ion stays as a polyatomic ion, you can treat it like a single atom, can't you? So how many nitrates are there on the left? 2. How many nitrates over here?
There's 1.
All right.
So you would have to put a 2 in front of that. And now you have 2 potassiums.
Yes.
So, but that's already balanced out on the
Ah,
other side.
there's 2 potassiums right there.
And then the chromate is already balanced on the
1
side.
chromate, 1 chromate. What do you think? Can it be reduced? Okay, number 6. Volunteer for number 6. Yes, Sarah.
So there's 3 hydrogens as a product, so you need to put 3 in front of the.
Wait a minute, but you notice there's 3 here, but you should tell them that there were only 2 here. That's an odd even mismatch, right?
Yeah.
Okay,
So
go ahead.
You put 3 in front of the hydrogen.
Okay.
2 and then 2 in front of the NH3.
Okay,
And then you're in balance because you have 2 nitrogen.
so that's 6 hydrogens and 6, I'm sorry, my fault. I put it in the wrong place, didn't I? Did you mean in front of the hydrogens?
Yeah.
Sorry. So now you have 6 hydrogens and 6 hydrogens, but now how many nitrogens do you have?
2.
And we already had 2, didn't we? So we leave that alone, don't we? Can you reduce it? All right, we're gonna skip 7 for right now. 8, volunteer for number 8. All right, go ahead, Matthew.
All right. 8's balanced.
Okay, now, if it is, what do I require you to do?
Right balanced.
Right, then I know that you noticed that it was balanced. It wasn't you just skipped the problem. And see that? You know, every year, I don't know why, I try to tell them this because I want to make sure that you looked at it, you knew it was balanced. And that's why you write balanced. Every year I give a test or a quiz, there's always one student, please don't be that student. After they balanced it, they wrote balanced, balanced, they wrote balanced in every one. That's not what I want you to do. I want you to put balance if it's all, so if, I didn't want you to have to write the word already. So if you want, you can. Already balanced. How about that? But every year somebody says, balance, 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 balance. I know the balance. You balanced it. Okay. All right. How about number 8? Dave, you said you wanted to do that one, I think.
Yeah. Wait, you mean 9?
I mean 9, yeah.
Well, for one thing, there are the chlorate is being broken up, therefore we must consider the individual atoms.
Excellent. Excellent.
And looking at the oxygens to begin, I noticed 3 in the chlorate on the left, only 2 oxygens on the right. That is what you would refer to as an even.
Odd, even mismatch. That's it. Okay.
Uh,
So how are we going to fix that?
Well, what first comes to mind is however you would call it, but 2 and 3 both go into 6.
Yeah, yes. And some math teachers have a name for that, don't they? Least common multiple. We don't have to call it that. Let's just say the smallest number, they both go into even. How about that? I-
Therefore,
So what are you going to put in front here, Dave?
2,
What are you going to put in front of here?
3.
Okay, but
To account for the 2 extra potassiums, right,
2 here.
for the
Sodium chlorate?
Potassium chlorate, chloride.
Right, potassium, yeah.
And but wait, this also meant 2 chlorines, didn't it?
Yes.
And 2 chlorines.
Yes.
All right, can you reduce it though?
No.
No. All right, 10. Somebody volunteer 10. Yes, Lauren.
So there's 1 magnesium on the left, and there's 1 on the right, so it's balanced. And then there's 1 hydrogen on the left and 2 on the right.
Oh,
So that is an odd even mismatch. And then also.
it's not, well, it could be odd even mismatch or just say it's a multiple. You could do that if you want, but
And then same chlorine.
what am I going to put in front of this guy? Okay. That gives me the 2 hydrogens, doesn't it? But it also gives me 2 chlorines.
Yeah, there's already 2.
Oh, look, there are 2 chlorines. Can you reduce it? All right, now, ready? Did you figure it out?
Yeah.
Yeah, you did?
Yeah.
Okay, so you give me the first coefficient, and you give me the second coefficient. What goes here?
4.
4?
That's number 8.
Oh, 4. And what's the next coefficient in front of the carbon dioxide? I can't hear.
12.
12, okay. What's the next coefficient?
2.
What it?
2.
Next. 10, woo, and
1.
and we don't write the 1, right? That's okay. All right, now we can't reduce it because you had a 1 here, right? All right, let's see if this works. Now, this is a hard one, okay? Now, what I'm going to do here, let's talk about how many carbons you have. What's 3 times 4? 12. What's 12 times 1? A lot of people think that 2 goes with the carbon. No, no, no. Isn't it C1O2? Isn't it? So it's 12 times 1 carbon. That's 12. Now let's do hydrogens. 4 times 6. Oops. 5. 20. 10 times 2. 20. 20 hydrogens. Yes? Now here's where it gets tricky. How many nitrogens? Watch now. 4 times what?
3.
Times 1. 4 times 3 times 1. That's 12 nitrogens. And how many? Oops.
So it needs to be
Let's try this again. 4 times 3 times 1, 12. Whoops.
6.
Let's put a 6 here, see what happens. Now, watch oxygens. 4 times 3, that's 12, times 3,
36.
36. Okay, whoa. What's 12 times 2?
24.
What's 10 times 1?
10.
10.
Oh, we're going to be close. And what's 1 times 2?
2.
Yay!
36.
You did it. All right, that a little tiny mistake there, okay? A little tiny one. Woo! Very, very good. You see how we had to do that? Look at oxygens again. 4 times 3 times 3. Yes?
How do you just come up with that though? Like,
All right. Unfortunately, I don't have any tricks for these kind, and it's just you grunt it out. It's trial and error. Trial and error.
Just put 4 in front and saw what happened.
I'll bet you started with 2 and it didn't work,
Yeah.
and you might have done 3 and it didn't work.
Mm-hmm.
And I understand. That was just one of those ones where you just have to stay with it. Yes?
So what's gonna be another question?
It would be a bonus question if I had one like that, okay? Okay, so don't worry about that. Yes?
so how did you get the 24? There only the
24, what, oxygens? Oh, not, 24 nitrogens? No?
No, there's just a 24.
Oh, okay. So I had a 36 oxygens over here, and I had to see, do I have 36 on the right? So how many oxygens are in the carbon dioxide? It's 2 times 12. That's where I got the 24. Then I went 10 times 1. That was 10. And then 1 times 2 is 2. And that came out to be 36. Good job. Good job, you guys. All right, well, let's do the next part. And if you want to practice, if you would like to practice, I could see this page here, for example. If you went home tonight and just classified and balanced a little bit, I think you'll be fine for 95% of the quiz. You get that? Now what I'm going to do is I'm going to go to, and I'm going to spend today, and even when you get back, I'm going to spend most of my time with the higher level part of this chapter, okay? Right now, 90% of the test has been covered. Even the test. It's that last 10% is what I want you to do, a little bit higher level stuff, okay? Yes?
I was gonna ask, how do you know when to reduce and not to reduce?
Okay, good question. You guys, you're going to ask some really good questions lately. Now, if every single, what if somebody had done this? 8, 6, 4. Can you divide all those by a number to reduce them? And you would have gotten 4, 3, 2. See that? Now, but notice that as soon as there's a 1, you can't reduce a 1. You have to divide all of them by the same number to be able to reduce it, don't you? So here, that one's already done, and that's a good question you had. But as soon as you get a 1 coefficient, you know you can't reduce it. All right. Now, some of you, I'm glad that some of you have a little bit of ego. I'm okay with that. Okay. I think I had some when I was your age. And some of you think, this is so easy. This is so easy. Okay, so what I'm asking you to do is just stay with me, and let's do the parts that's a little bit harder. All right, find a partner, and I want you to do number 1 and 2, and I don't know if any of you will get both of these right. So let's try it. Find a partner, sit with somebody and said, we're going to do number 1 and 2. I want you to balance it. Libby, you need to sit with somebody. You can do this. All right. Who do you want to sit with? You want Dave? All right. You want to go with Libby? All right. Libby's going to ask you a whole bunch of questions. All right. She's going to ask a whole bunch of questions. You're going to help her. I want you to turn it into a chemical equation, balance it, and classify it. Balance it and classify it. Oh, I mean the first three. Did I say the first two? Do the first three, okay? If anybody in this room gets all three of these right, I'd be impressed. I will be impressed. Can you see the periodic table from there?
Yeah.
Okay.
So it's the same.
Do you know why I gave the retest? You know why I gave the retest on writing formulas? Because if you can't write formulas, you can't do this. We're doing the first three, okay? Let's do the first three. Now, I might have one of these on the quiz, but I'll have a lot more of them on the test. You get that? So only one of these, this type, will be on the on the quiz tomorrow. And this is real chemistry. This is when you get your really good chemistry students, when you be able to do this. I went to the band concert last night, so I was not able, or the choir and band, I was not able to grade the retest, so you'll have to give me a little extra time to do that. All right, Dave, are you guys talking? You should be talking. And Libby's going to ask a bunch of questions, I think. She's going to say, how did you know to put that there?
What's the difference between like what's bromine?
Ah, bromide must be a binary compound. Oh, that's bromine. Oh, bromine. The element bromine.
And
Bromide is you're in a compound. This is not in a. This is. Ah. All right, how many of you have the first one done? Raise your hand if you have the first one done. All right, raise your hand if you have the second one done. Raise your hand if you have all three of them done. Okay, let's do the third one. I do want to go over these, so about one more minute. One more minute. You guys got the first three? You guys got the first three, Leroy? First three? Wow. You got the first three? Wow. And when I show you the answers, I want you to be honest with yourself and said, I really did get all three of them right. And I'd be very impressed. Okay? If you made a mistake, it's okay. We're just starting this out. But we'll spend a lot of time in this before you take the test. But the quiz will have one of these on there. Yes? The quiz would be where you balance equations and classify them, and they'd be like we just did all day today, except I might have one of these, okay? All right, you ready? I need to start now because you actually go to lunch at 25 after, so I have to start now. If everybody come back to your seats, or if you want to stay right there, and talk to your partner and say, oh, we forgot. Okay, here we go. All right, here's what I think should have happened here. Ready? Zinc, there's zinc, plus lead 2. I'm hoping you did that. Lead 2 what? But nitrates minus 1. Uh-oh. I'm hoping you did that. Are we in good shape?
Yeah.
If you can't write formulas, all right? Yields what? Zinc nitrate. Now, wait a minute. Zinc is always plus 2, but what's nitrate? Well, that won't work until you do this. Huh? What do you think? Huh? Everybody eyes open yet? Oh. Okay, plus what? All right, now, before we balance it, let's classify it. I ask you to balance it and classify it.
Single replacement.
Yes.
Yeah.
Very good. Now let's balance it. Ready? Scan, scan, scan. I noticed 2 nitrates, 1 zinc, 1 zinc, 1 lead, 1 lead.
Sir, let's go, sire.
You should have written balanced.
What we're talking about.
All right. How many people honestly got the first one right? Okay. All right. Let's go to the second one. Ready? Aluminum bromide, AlBr. I know it's binary, but bromine's minus 1, but aluminum is always plus 3. Yes. Yes. And here's where somebody's going to trip. Sorry, you're going to stub your toe on this one. Why did you do that? Because when chlorine is the element chlorine on this planet, it's what? It's diatomic. Okay, what's the next guy? AlCl, but chlorine's minus 1, and aluminum's what? Ooh. And what do you do here? Oh, that's also a diatomic. Everybody remember the diatomic elements? They end in gen, they end in ene. Okay, now, let's classify. Classify. Can't be double replacement because I have AB, but I don't have CD. In this case, it's a non-metal. Look at this one. Metal kicking out a metal. What's this one? Oh, non-metal kicking out a non-metal. All right, let's balance. 1 aluminum, 1 aluminum, 3 bromines, 2 bromines. I'll fix that. But wait a minute, that gave you 2 aluminums. Oh, I'll fix that. But wait a minute, that gave you what? 6 chlorines. Can you reduce this? Honestly, did you get number? Raise your hand if you got number 2 right. That was the hardest one because of diatomic elements, wasn't it? We got one more. Ready? Sodium phosphate. But phosphate's minus 3 and sodium's plus 1. What are we going to do about that? All right, plus calcium chloride. But calcium's plus 2 and chlorine's minus 1. Ooh. Yes? Yes? Okay. Yields calcium phosphate. But phosphate's minus 3 and calcium's what? How are we going to fix that? We just had a whole chapter on that. Yeah? Okay. And then what? What's next? Sodium. All right, let's classify. Very good. Now let's balance. Ready? Scan, 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 scan. I'm going to do the polyatomic ion first. 2 phosphates, 1 phosphate. Now I have 2 phosphates, but how many sodiums? 6. Woo! But wait a minute. That gave you how many chlorines? 6. Only 2 here. How about, is that 6 chlorines now? But that's 3 calciums. Oh. What do you think? Raise your hand if you honestly got that one right. Okay, so we have about 30 seconds here. What was it that, diatomic elements, I bet that got you, didn't it?
Yeah.
What about, how about writing formulas? Did that get you? No? Great. All right, so what did you get you? Just the diatomic elements? That only showed up on 1. All right, have a good lunch. You did a great job today.